Good day, everyone. Today is November 16th. This is an S244 wood stove, and I am trying to get it so it doesn't smoke. I'm trying to get everything in the shot here, and the real key thing to me is that PM monitor. So I'm trying to get everything in the screen there. There we go. Okay, you can kind of see this. So in this configuration, this controller is controlling this fan and this fan, which is controlling this plenum tube for the air going into these top vents. If I don't have this piece on, I get smoke coming out of these vents, and it's evident here on this PM 2.5 monitor. Hopefully you can see that. It says 26. If we can keep that under 50, we have had a successful test. I've got all my fans running. The fan under here is on manual control. These fans are controlled by this device. I've raised the temperature limit to 450, and data acquisition system is ready to go. I'm starting my timer. Starting data acquisition system. It is 57 degrees. To start my fire, I put 2 scoops of pellets a wax fire starter log, right in there like that. So, taking a look at my phone here. Time is 10:24. You can see there's a fire in there. I'm just gonna leave it. It's gonna take an hour for this stove to warm up. So I think I'll just leave the camera running and clean some stuff up. Maybe change some of the lighting. This video is 21 minutes long. I occasionally will speed it up so that, well, you don't have to watch it all. So the instruments that I use are a stopwatch, a PM 2.5 monitor. I have a data acquisition system. I'll put graphs up. And I think the PM 2.5 goes south up to really high here in a few minutes. You notice that there's a fan on the bottom, and there's a fan, two fans on the manifold on the top. I'm going to be talking a little bit about that manifold and how I constructed it. The idea is you need to create a high pressure area right in front of the vents on the top of the stove, and this is an area that can get rather hot while you're operating the stove. You see now that the PM 2.5 is 81, so the room, this is not what you'd want in your house, and it's what I'm working on, trying to keep the air quality in the house or in the living area with low particulate count. This is the manifold. I took a rectangular piece of aluminum and cut a pocket out of it so that it would cover the vents that are there. I'll have a couple of series of photos on that, renderings showing how I constructed this and how it fits on there. So this stove has a air wash, and that's what the primary air vents. Those vents push air down the window. I made the manifold that's on the upper side by putting this a 50 by 25 millimeter rectangular tubing in my CNC and cutting out a section, and then I use some turnbuckles to pull it directly back at the wood stove, so it is snugly pressing against the front of the stove, covering these ports that I have shown here in green and white. This stove works best with a small high pressure pushing air into the stove. If you had a vertical chimney, and I don't think I mentioned this yet, the chimney on this test apparatus is horizontal. There's no natural draft, so it gets all of its draft from the fans. And that's part of the experiment. You need to create a high pressure zone right in front of these vents to keep smoke from pulling out, being pushed out by the fire and influencing the PM 2.5 monitor. You may not be able to see the smoke. However, you eventually figure out that it's putting smoke out. I'm going to disturb the fuel. This is something that needs to be done on occasion. It exposes more surface area. Right now I'm opening the door just a sliver or just a crack to allow more air in. Hovering at 300 degrees. It appears this stove really has to be at 300 degrees before it runs correctly. I'm going to try to find some more dry wood. I placed a chart in the right corner, and we are right in the middle, right above time. It says 1.5. So what I see here is that the initial fuel we put in has. Here's a nice piece of maple. Let's check it out for moisture content. 8%, 8-9% moisture content. That's a piece of dry wood. I could do something with it, but it's really too small. It's got a nice live edge. Makes no difference to the wood stove. Oh, I'll give you a weight on it. That is just over a pound. It's 638 grams. 638 grams of very dry wood. If you look at the graph, you can see we're almost in the middle of the graph. And I'm putting on a piece of maple, very dry maple, and you can see the temperature rise. I'm trying to get this wood stove up to its limit. I'm testing the firmware that's on the microcontroller to determine whether it'll control at the higher limits. So I'm putting as much fuel as I can fit in the stove and getting the stove as hot as I can. I want to see that the fans will throttle back and turn down so that it keeps it below a certain threshold. I'm pushing air through the top vents here that are shown by the aluminum extrusion. And there's 2 fans. Later in the week, I went down to 1 fan and I had much better results. I think I'm just putting too much air into this wood stove. And putting too much air into a wood stove, either by natural draft or by forced draft, like I'm doing, is not the way to have an optimal burn. We want to have a proper burn, or the best burn, a stoichiometric burn. And we need to be able to regulate the airflow with minute changes. Every 5 seconds, it recalculates and puts in a new amount of air. So the graph I've got here is the testing from today, but the graphs I'll show after this were testing I did later in the week as I was editing. You can see that I made it to 500 degrees Fahrenheit at 2 hours. So I'm just at that point right now. Update, we are shell temperature of 401, 392 on the stack. So we are over peak. We are past our peak. And our voltage is 8 volts. All right, so what can we do here? I would like to add some more air. That's pretty hot, pretty warm. Let's see, we are at, it's 100 degrees, 90. It feels a lot warmer than that. Well, right here we are at 600, almost 600 degrees Fahrenheit. Right here we're almost to 600. So I'm going to go find some more fuel. First I'll make some room. That piece of maple is just about gone. stove is in the zone now. Alright, I'm going to go try to find a small piece of wood because I want to get this thing up running around 450. So again, we are at 397 on the shell. We are at 416 on the stack. PM is 106. We're at 2 hours to get it to this point. The room is starting to heat up. It's now 66.6 degrees. More fuel. This is the chart from a couple days later, and I really think I reprogrammed the microcontroller a bit, and I'm using one fan for the chart. Visibly, you see three fans actually on the wood stove. And I'm controlling them both with the controller. Now take a look that I'm able to keep the blue line between 400 and 500 degrees Fahrenheit for at least 2 hours. And that is because I was able to put a lot of fuel in there, but the fans will regulate it so that when it drops, it'll put more air in. And when I put too much fuel in, it'll restrict the fans and not put a lot of air in. And that's what I think wood stoves have to have in the future, is they're all going to have some computer controlled regulation of the airflow. One of the things that I worked on this week was how to figure out how much burn rate or how much fuel this burns in an hour. And I did that by weighing a piece of wood and measuring the temperature, and then when the temperature got back to that same level, I would put another piece in. And so I come up with 2.4 pounds per hour for a piece of maple and 2 pounds per hour for a piece of fiber brick. And the difference may be the amount of air I'm putting in. But that's consistent with the test report I found from that this wood stove had been put through. Their burn rates range from 0.82 kilograms per hour to 1.8 kilograms per hour. And I'm right in the middle of that. So I feel like I'm not outside the envelope of this wood stove. We are nearing the end of the video. This was a 2.5 hour burn for the backdrop video. It was conducted on the 16th of November 2022. Since I started that burn, I've run several tests, keeping my shop warm and refining the software and the procedures to make this work. And the stove is running quite well. I'm able to keep PM 2.5 levels in the shop to a reasonable level. I'm able to heat the shop to a reasonable temperature. And the stove is working quite well. Most of my work is with a low-pi Revere, which behaves quite differently to the combustion air fan than this one does. The same program works on both. So the software that I've got on the microcontroller doesn't need to change much. However, I will say that it's working quite well in getting the ramp up to temperature, controlling at the high levels. The next phase of my software development will be to control when to refuel, notifying the operator when to refuel. This has been really fun. I really enjoy watching fire. I really enjoy working with fire, and I'm hoping you're enjoying watching this video. We are Smokeless Chimney, warm homes and clean air for everyone. You can find us on Facebook, Smokeless Chimney, You can find us on Reddit, Smokeless Chimney. I even have a Twitter account called Smokeless Chimney. But I really want to make wood stoves work better, and very soon I'll have my opacity system tied into the microcontroller, and we'll be able to measure the opacity of smoke being exhausted from the wood stove. Smokeless Chimney, www.smokelesschimney.com. Warm homes and clean air for everyone.